So, morning, good afternoon, everyone. Yeah, according to my time, this is 1:30. So, this is the voice of Dream, the creator of GeoVES from Just Light Studios. So, right now, I want to take you guys on how to make use of Just Light Studios. So, from here, you go to our URL, whichever browser you're using. Could be using Brave, whatever, or Chrome. So, for me, I'm using Chrome. So, the link is GeoVES iPhone Geo iPhone VSX dot lovable dot app. So that is the web app. Click enter, then takes you to the web app. Now from here you can see from your screen, this is the dashboard. Now we have, when I scroll down, these are the generic or the data precepts from previous fieldwork or field data that was acquired. These are free, I call it sample data. If you can check from here, let's check what we know, the groundwater expression. So if I should click here now, these are the quick data sets from the dashboard I picked. So if I go here, we have the dashboard in the workflow section. We have the dashboard, we have the data input, we have the processing, we have the visualization section, we have the compare section, we have the export. Now, what matters is mostly for us just to see how it works. I just clicked on the groundwater stuff, expression stuff. Now you go to processing. Now, whichever interpolation method you pick and better, this one just runs it as it's meant to be. Why this one is the filtered one, as how it's meant to progress, the normal regression. Then you click on generate 2D section, then you're getting your geoelectric section. Now, if you want to plot your geoelectric layers, you click on this icon. Already it has generated your geoelectric layers. Right now, I just showed you the sample of how GeoVES works, which is created by Just Light Studios. So right now, if you want to export the data, you click on export, then you export PNG. And from here, that's been exported for my download. Just need to click here. This is it, right? Now, I want us to take back. For example, you're working on the fresh data acquired from whichever sites you are working on. You want to make a geoelectric section from your multiple data you have acquired. All you need to just do is, maybe if you have taken, just restart the website, web app again. Or if you have clicked, you come to, if you have clicked here by mistake, you can simply just come here to data inputs and delete all this. But I want us to restart again. Now, the first thing that first comes is your dashboard. For us to input our feed data that we acquired from using our YAM for our VES array, whichever one, which is Lombardia, when now, whichever one you've acquired from your feed data, just simply call the data input, as that said in the workflow section. Then you start by here. Now, luckily for us, we have a feed data acquired from one of our team, which is Mr. Zeke. I'll be using his feed data that has been acquired by him. So, and this is the feed data that's been acquired by a total of about 19 VES data. But I will show you how you can use it, how you use it to work with it by showing his base map. So, and this is his base map. And this is his base map. So we'll come here back. So this is his base map. From our screen, you can see here, this is what Mr. Zeke from our team has acquired his data. Now, if you look at this, we'll be using this base map as a sample in order for us to understand how GeoVES web app works. So from here, we could see that we have, about 5 canvases. So from these 5 canvases, I will just be picking on 2 canvases on how we can use those traverses on those verse points on those traverses to make a geosection. So now, if you look at traverse 1, we have verse 1, verse 2, and verse 3. Then I will come to his data set from the from the Excel sheet. Now, if you look at verse 1, has about how many layers? 4 layers. Then now you go to your GeoVES, which has already been the data section. You run write in caps verse 1, because that's where we're starting from. The position, simply come. Each traverse line is about 100 meter, plus minus 100 meters in length. And from here, we can see that verse 1 is at maybe as at 0.10, 0.15, and 0.45. Verse 3 is at 0.45. So the distance that was the verse was taken at one traverses for this traverse 1. So here I will go back to the geosites, the GeoVES web app. Then I'll put 15 because that's where the verse 1 was located at. As you can see, 15 meter. Then I come back here. Then elevation, whichever elevation, if you have taken elevation in your data reading, you can put elevation there. If you've not taken elevation data reading, you can leave it at just 100. Now we'll come here. So, pardon me, guys. So I will have to use these settings so as we can understand it better. Hold on. Okay. So now, verse 1, I said verse 1 has a total of 4 layers. So we start. So we start. So we start. Layer 1 has 250.7. Layer 2 has a resistivity of 353.6. Layer 3, that was layer 2. Layer 3 has 170.9 resistivity. Now, like I said, we have 4 layers. So you now click here. You click on add layer. So click on add layer. Sorry. So we've clicked on add layer. So you can, if you want to remove, maybe let's say you made click too much. If you want to delete SS layer, you just click this delete icon, this trash icon, and just delete. So now, like I said, layer 3 is about from the data set from the Excel sheet. We have 170.9. Now layer 4 is at 2515. Now we now come to the thickness 3.7. Come here 0.5. Now if you can see, I have just been typing the thickness, but automatically it is generating the depth by itself. You don't need to just put the depth. Once you just click the thickness, it will generate the depth itself. So 44.9. Now you can see it's done. So now when you are done with one verse point, you just add station. Now you could see from this cursor, you could see that verse 1 has been added, loaded stations. That means verse 1 has now been loaded into the website, has been read and stored into the website. Now into the app, into the web app. So now you come to verse 2 because we're working with 3 verse points at one traverses from that base map earlier. So verse 2, I said 15, 30, and 45. So now we have 30. Since we don't have elevation, we just leave elevation as 100. Now verse 2 is at what? To see how I correct, so we look at it. Verse 2 is at how many? Same thing with 4 layers. So I can just come in to be fast, click my 4 layer. Now 316 and 7. So I've clicked. So now we start verse 1.7. Now just the layer 2, we have 267.6. Layer 3, we have 231. The layer 4, we have 346. Sorry, 346. So then we come to the thickness. So we have 2.1, 2.1. We have, let's check in case there's an error. 2.1. We have 1.7. And the third layer, we have 6.1. So now, you're done with verse 2, load station. Same thing, work with verse 3. Verse 3. Why I made this station name in caps, so that when it comes to generating the geosection, it will be in caps. You can use small letter, you can use lowercase if you want. Now, I said the last layer is 45 meter spacing. That's where verse 3 was located at. Now, we come here, 318. This is it. I'm here, 318.4. So I click here, 96.9, 361. Yep, 361. Now we have same thing. This one's a 4-layer case. So we have 234.2. Now we have 0.71. 4. So the load station. That's all. So once you've done it, you scroll up. Now you have done to know if you have inputted your distributor. This is to show your best points. The loaded station has to read it for you. So looking at this, our inputted best data has been shown. So that means we are good to go. Now go to the processing workstation. Now, like I said, we have two interpolation methods. This is the normal one, just runs the regression. Then this Gauss-Newton runs it by filtering it, smoothing it. So I can choose whichever one. So I will just go with the Gauss-Newton and click generate with this section. Then we have it. So you could see this is it. Now this is okay for me. I could know this is for my resistivity. I could know this is my legend. I could know from the resistivity I can infer the lithologies for this. Now, if I want to show geoelectric layer, all I do is to just click show geoelectric layers, and from there it's been generated already. So if you are done, just come to okay. Before downloading, you can also generate your own manual resistivity. If you don't like 123 to be your minimum, you can reduce the minimum further by making it, let's make our minimum 100, or let's make it 50. Let's make it 50. Let's make it 50. Let's make our minimum 50. I will make our maximum 1000. So we could see from here, this is it. This is my preference, but if I don't want, I can just leave it to automatically generate itself. Then when you are done, click export, then export your geosection. Now from here, I'll click, I can click here, or I can just click on my download button. So this is it. This is the generated geoelectric session. So this is the, so now this is on, from this we can infer that we've gotten the geosection for transverse 1, and that is it for here. This is it. Now we want to talk on for the transverse 2. We want to call transverse 2. So now for transverse 2, according to the base map from our respected colleague Mr. Zik, So we've done traverse 1 and as an example. So we pick traverse 2, and traverse 2 has how many points? We have um verse 4, verse 5, verse 6, and verse 7. Yeah, verse 7. So we'll work on that. So we'll come back to the web app, go to the data inputs. So this was the previous one we inputted, the previous verse points. So we delete them, delete them, then we start again. So start with verse 4. Verse 4. That's 15 now. So verse 4, we have how many layers? 3 layers. We'll start 202, 412, and 184.9. Now for the thickness for 202, we have 2.8 meters. For 412, we have 3.6 meters. So add station. Now, verse 5. Verse 5 position was about 45 meter. Since we don't have elevation, you can just leave elevation there. But if you have your elevation data, you can add your elevation data just to show the topography of your geosection. So verse 5, we have 5 layers. So 198.4 for layer 1. Layer 2, 371.4. Then 901.3. Now just add 2 more layers. So 131.3 and 99.7. So the best way you can make use of GeoVES for now is with your PC, your personal computer, so as to get the full experience of the usage of it. You could make use of your tab or your phone, but make sure your view of your browser should be in desktop view. Thank you. So now we're back to where we are. So at verse 5, at layer 1, we have 1.1 meters thickness. Layer 2, we have 2.4. Layer 3, we have 12.2. Layer 4, we have 1.1. So add station. So now to cross-check how many base points that we are working, we go back to the base map. So like I said, we have verse 4, verse 5, verse 6, and verse 7. So verse 4 down to verse 7. So we'll come back here, then we'll come back to our web app. So our GeoVES. So verse 6. So we have at 60 meters. So now you pick how many. So we have about 4 layers. So to be fast, I'll just click on the total layers we have. So 117. That's 9. So the layer 3, you have 12 meter. For verse 6, this is it to fact check. So add station. Now to see the full of verse 7 for the data points here from the Excel data sheet. So our station number, always put a caption so for better visibility. So now verse at 90, position 90. So we could start. We have about a total of 4 layers. So we click on add layer to make everything 4. You could see this hashtag, like I said earlier. So let's go in speed. So from here, we could say our best points are loaded. Come here, this is the data. We go to the processing. Now, as earlier much, I use Gauss and we use Gauss again. You could use, okay, let's change, still the same. Let's make use of whichever one. Let me just show you how it's the difference between the two of them. See this, look at this. Let's off the geoelectric section. So look at this, and also look at this. If I go back to processing and I click on bilinear, still give me similarly just filtered form. If you look, if you check, it's just the filtered form of the previous one. So click on show geoelectric layer. Now you could see that since we want to show geoelectric layer just for mapping each layer, and you could see that they are not uniform or doesn't really make sense. You just come to this icon, which it says what? Snipping to freehand. So we click on it, then we start. You could say here should be our first layer. So when you are done, double tap. So make here our second layer. So I just turn this geosection that has about a maximum of 5. I think the highest point of one of the verse points is about 5 meter, 5 layers, and I turn it into a 3-layer geosection. So this is what this snipping tool does. It helps for you to map your geoelectric layer manually or freehand. That's to the preference of the user. So this is it. So this icon just to show how you want the view to be: large, medium, small. For better visibility, I will increase my web browser. So look at this is the small, this is the large. So this is how it is for better visibility. I could just erase all of them. Let's do it again to make it easier for us to understand. You click, you click, you click. So this black dash are the verse points and the layers of each verse point. So you could say this is our first layer. So when you are done, you double click at that end to finish your geoelectric layer you are trying to map. Then you click again. Let's make this two together. Click here. Okay. Let's erase them first. Let's erase them first. So we just shift. So clear all. So let's start again. Click. Let's start like this. So this box following this my cursor is tracking the verse resistivity value. It's a cursor tracker. So this you can see it's tracking the depths, tracking the elevation, tracking the resistivity as the cursor is moving in this geosection sheet. Now to map the second layer, because this why I'm mapping this geoelectric layer manually, because most times we cannot have uniform layers when we've gotten our feed data from our verse points. So this is mapping it to my own preference. So you can see this is also another way of mapping it, and I'm done. Look at it was different from the way I mapped this first one. Whichever you will map it, it's to your preference. So this is my first layer, my second layer, my third layer. So that's what the tool does. So when you come here, you don't need to save it here. When you come here, just export it and you're done. This is just to show areas where the geoelectric layers are not uniform across the base stations for a geoelectric station. So this is it. You can see. So from here now, we can infer that this is a fresh basement. Can infer that this is a sand or a kind of laterite, a weathered layer material. You can find that this place is a clay material, whichever how you tend to interpret it to your preference and to how you assign the lithology. So I will, so that's all how so and that is how you make use of GeoVES made by Geoslide Studios. And my name still remains Dream, the creator of GeoVES. Thank you very much.